I think we're live. Okay, so number one, I ask a question like, what is a radian? Because I really want you to understand what a radian is. I could take a picture. For example, you could do this. If you want to give me a picture, so theta is an angle, and angle whose measure is equal to its arc length. So this angle is 1 radian. It is an angle though. It's an angle. A radian is an angle that equals, and that's 1 radian right there. What we have is 1, that is a picture of 1 radian. When I have an angle of pi 6 radians, that's the angle, and the arc length is also pi 6. I have an angle of pi, that means the arc length is pi, where the angle and the arc length are connected and the same. Okay? How's that? Okay, number 2, convert the following. So I look at my notes. I'm going to take it from radians to degrees, from degrees to radians. So we're going to go degrees to radians. So I'm going to use my formula. So I'm going to say, okay, R, my radian, is equal to 250 over 180 pi. Now, if you can keep it in terms of pi, please do, because we like radians in terms of pi, because it helps represent the circle. So that'd be just 25/18. You guys okay with that reduction? So 25/18 pi is a fabulous answer, okay? Like that answer. Okay. B, well, I've got this little notch. What's this little notch mean? Minutes. So what I really have is 134 degrees and 24/60ths, right? So let's figure out what 24/60ths is first. As a decimal, that's about 0.4, so I'm going to have really 134.4 degrees. And I'm going to use my formula. I'm not going to be able to keep it in terms of pi because of the decimal, so that's all right. I'll just get a decimal answer. So I'm going to go 134.4 over 180, and then Carly times pi like that. Does that help? How's that? Times pi on the top. Okay? And I'm just going to get a decimal answer of 134.4 times pi divided by 180. But 2.3, we'll go to nearest thousands, 2.346. 2.346, and that is an angle. It doesn't look like an angle, but that's an angle. That is an angle in terms of radians. It's almost all the way over to pi, 3.14, but it's not quite there. Number 3. So if I'm going to convert to degrees, I've got my formulas. I'm going to use this one, radians to degrees. So I'm going to go, okay, my degree is equal to 180 over pi times my angle. My angle is my 7 pi 12ths. This one's kind of easy because things are going to cancel. I like that. So my pi's cancel. I'm just going to use my calculator. 180 times 7 divided by 12. About 105 degrees. Okay? Stop me if I get going too fast. What are you doing? Okay, 1 thumb up, 2, 3, 4, 5. Okay, good. Okay, B. degrees and minutes. My answer's got to have minutes in it, but let's get to there in a second. So I take my formula. I'm going to go 180 over pi. And then I'm going to times it by this 4.23. And so that's what my degree is going to equal. My radian is going to equal. Sorry, my radian. No, my degree. Degrees and minutes. So it's my degrees. Yeah, okay. So 180 times my 4.23 divided by pi, and I get an answer. So I get 242 degrees and 0.3611 blah 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 blah. Okay, so I want to change the decimal into minutes. So I want to multiply the decimal times 60, just the decimal. So the easiest way for me is I'm just going to use my calculator, subtract out my 242, just get rid of the degrees, right? So if I go minus 242, then I'm just left with the decimal, and then I can just easily multiply that times 60, and I get my minutes, which is about 21, we can round it to 22 minutes. So I'm going to have 242 degrees in about 22 minutes. Okay, so I use the formula. I got a degree with a decimal. I wanted the decimal times 60, so I just used my calculator to subtract out the 242, multiplied the decimal by 60, and I got about 22. All right. Okay, unit circle. Let's see what we have. So my circle is here. Sine is the y value. 5 pi 6 is here. My y value is 1/2. Okay. Tangent, negative pi thirds. It's a rotation. Pi thirds rotates to here. There's pi thirds, but I'll rotate backwards. So the tire goes this direction, rotates backwards. Well, right here, I'm looking for the tangent value, which is in mine, or on pink, which is negative square root of 3. Okay. Cosecant. Now, cosecant is 1 over the y value. Okay, so 3 pi fourths is there. The y value is square root of 2 over 2. So I get a 1 over the square root of 2 over 2. I've got 1 over a fraction, which just flips the fractions to reciprocal, which is 2 over the square root of 2. Multiply square root of 2 to rationalize it. And I wind up with 2 square root of 2 over 2, which is just going to be a square root of 2. Okay? Now, write yourself a note. I'm going to find the angle. Find the angle. How do I know that? How do I know I want to find the angle? It's the inverse, right? So let's find a y value closest to 0 of square root of 2 over 2. It's right there. It's pi fourths. And it says in terms of pi, so it's got to be pi fourths. It's in radians. Pi over 4. Arctangent, it's the same thing. They call it arctangent because you really, not only are finding an angle, but you're finding an arc length. Does that make sense? They're both, right? So you see this arc, it's like, okay, well, what's the arc length? Tangent negative 1 is here. So it would be a negative pi fourths. Now this is one where you could argue and win your argument and say, no, it's the same as pi fourths, because if it's really an arc length, I would take either one, okay? I would take either one. Because if it's an arc length, it has to be a positive value. Negative pi fourths, you're probably going to be more comfortable giving, okay? Now, secant. This is the same thing as 1 over cosine. Thank you, Brittany. 1 over cosine of theta equals negative 2, right? Because there's no secant on my unit circle. No secant on my calculator. Okay, so I'm going to reciprocate. I'm going to flip them both. And I'm going to have cosine of theta equals negative 1/2. I'll look for my unit circle. I'm looking for an x value, right? X value of negative 1/2 is here, right here, 2 pi thirds. 2 pi thirds. All right, 10. The area of a sector is 20 centimeters wide with a central angle of 0.8 radians. Okay, find the radius and the arc length. So I like to write down the symbols. I like to write down what I know. Okay, so I have an R. I want to find my R. I want to find my S. I know the area, so K is 20, and I know theta is 0.8. Okay, so I look at my notes, and I'm looking for something with these variables in. Okay, so I'm probably going to use this formula first, because I've got K, and I have theta, but I can find R. Okay, so I'm probably going to use this formula first. I have K, I have theta, I can find R. So I'll probably use that one. That makes the most sense to me, so I'll start off with K equals 1/2 R squared theta. My area is 20. My radius I don't know, but I'm going to find that out. And my theta is 0.8 radians. Okay? So I like to write down what I know, the variables. Look at all the variables and then find the formula that fits. All right, to solve, I'm going to multiply by 2, and I'll have 40 equals R squared times 0.8. I'll divide by 0.8. I'm running out of room, but that's the way it goes. Okay, I'll use my calculator on that one. What is 40 divided by 0.8? I get 50, really. Okay, so then I get R squared equals 50. R is the square root of 50, which is about 7.07 or something like that. Hold on. Square root of 50. Yeah, about 7.07. So that's the radius. Now, I want to find the arc length. Well, the easiest formula, if I look at all my formulas, is that one right there. Right? That's the easy formula. So let's use that formula. S equals R theta. So I'm going to find my arc length. I'm going to squeeze that in over here. S equals R theta. S equals the square root of 50 times 0.8, 0.8. Sorry, it's so sloppy. There we go. Use my calculator. Let's multiply that times 0.8, and I get an answer of about 5.65 is the arc length. Okay, what do you think? Okay. 11, I'm probably going to do on a separate sheet of paper. It's just not going to fit. So, yeah, I'm running out of room, so I'll do 11. I'll do 11. I could even do it on the back, okay? I'll do it on the back. Okay, so if sine is equal to negative 3/5. Okay, so between, what does this mean? What? Hold on, what's this? Well, let's see if I can draw a picture. 0, pi halves, pi, 3 pi halves, and back to 2 pi. Okay, I'm going to draw a picture first. Okay? So what I've done is I've looked at this first piece. My angle that I'm looking for is in quadrant 2 or 3. How do I know? It's in between. It's in between pi halves and 3 pi halves. So it's in between here and here. Okay? So the angle I'm looking for is either in quadrant 2 or in quadrant 3. Can't be in both. So we have to have more information. And we're given more information. Okay? Well, the information we're given is this. Sine is equal to negative 3/5. Okay, let me turn that over. My sine of theta is negative 3/5. Okay, now think about it. Sine is the y value. That's a negative y value. Where should it be? 2 or 3?
Can you go down a little bit?
Yes, I sure will. I'm sorry. I'll wait for you. Okay.
1, 2, 3, 4. Oh.
So the angle we're looking for is either in quadrant 2 or quadrant 3.
Oh, no, it's negative 3 and it's a positive 3.
Huh?
Is it a negative 3 and a positive 5 on the bottom?
It could be, but the radius is always going to be positive. Great question.
So then
Now let's see why it's got to be quadrant 3. Okay? Okay. So the sine of any angle is always going to be like the y value, isn't it? This one's the y over the x value, right? I'm sorry, over r. The radius is like a length, so the radius is always going to be positive. The radius is like a length. So what I really have is like a -3 over 5. Well, if I had to graph a -3 y value, it's going to be quadrant 3, right? Here's positive y's, negative y plus. All students hate calculus goes back to the fact that sine is positive here. That's not a positive sign, is it? Negative, which forces us into quadrant 3. So we're going to draw a triangle, quadrant 3, okay? I want to go slowly enough on this that it makes sense to you, okay? So, first of all, sine is negative. It has to be in quadrant 3 or 4, either one of these, right? But we already know, we're told the angle itself has to be in quadrants 2 or 3, okay? So we draw a triangle in quadrant 3. I'll go over this again with you when I'm done, okay? If you're still confused.
Wait, why does it have to be quadrant 3?
The very first piece, yeah, so let's rewrite this from pi halves less than or equal to theta less than or equal to 3 pi halves. Okay, so here's our first piece. It says our angle is between pi halves and 3 pi halves. That's our first piece of information, okay? So we've got two choices. Either from here to here, it's either going to be in quadrant 2 or quadrant 3. Then the third piece to this, since sine is negative, it has to be in quadrant 2. I'm sorry, quadrant 3. So I'm going to draw a triangle in quadrant 3. Here's my theta. What I know is that my y value is -3 and my radius is 5. The x value, 3, 4, 5 triangle, right? You guys agree, 3, 4, 5, or I could just use Pythagoras theorem. Anybody want me to use Pythagoras theorem? Sure, why not? So a squared plus b squared, or x squared plus y squared equals r squared, right? I need the x value. So I get x squared plus a -3 squared equals 5 squared, right? So I'm just proving this has to be 4, but we'll show it. X squared plus 9 equals 25. Subtract my 9, x squared equals 16. Square root now. Plus or minus? Plus or minus square root of 16? Well, we know it's 4. But is it plus or is it minus?
Wouldn't that be plus, you wouldn't get on a negative line, or would it be not minus because it's
It's got to be minus. How do I get from here? Back and down. Right? If I look at my unit circle, right? Price got a big game tonight. He's going to be okay. So if I look at my unit circle, remember we wrote this? Negative, negative, right? So if you're in quadrant 3, x is negative, y is negative. So here's what I know. X is going to be a -4, okay? Now, let's answer these questions. We need cosine, tangent, we need the ratios, right? I want the ratios. So, I know that sine of an angle is, oh, we already did sine, is the y over the r. I already know sine. Sine is -4/5, right? I know that. That was my question. Cosine of theta is x over the r. Okay, I'll step back.
Wait, isn't the sine negative?
Yes. I was ahead of my brain was ahead of me, wasn't it? Thanks, Ellie. Yeah, -4 over 5, right? For cosine?
Oh, okay.
Let's write them down. Let's write down what we have, okay? It's helpful to write down what we have, okay? We know that it's always helpful to write down what we know. I know my x value is -4, right? I know my y value is -3, right? And my radius is 5, okay? So now, cosine's just going to be -4 over 5. My tangent of theta is my y over my x, which is my negative 3 over negative 4, or positive 3/4. My cosecant of theta is my r over my y, but it's the reciprocal of sine anyway, 5 over negative 3. My secant is the reciprocal of cosine, so it's the r over the x, which is just the 5 over negative 4. And my cotangent, which is my x over my y, which is the reciprocal of my tangent, which is going to be a 4 over 3. Can you do that tomorrow? Possibly? Okay. Yeah? Okay. Okay, and I'll turn this when you give me thumbs up. So build a triangle. If you get your negatives wrong, I'll only take half a point off. Okay. Okay, turn the page. Now, 12. Let's just have me draw a picture. And I'm going to draw it on the whiteboard because it helps. Here's you. You're standing on Earth, and you are looking in a telescope, and you see Mars. And you get this thing called an apparent size, which is a really small little angle. Now, this is totally drawn out of proportion because this angle will be much smaller. So this angle is about 0.00014. And the radius, or how far away, is 5 times 10 to the 7th, okay? Now, the best way to see this problem is to imagine a gigantic circle of orbit. Okay, gigantic circle of orbit. Let me move this rag out of the way. Okay, I drew a gigantic circle. So, okay, think about a gigantic circle. Can you see it? Gigantic circle. And that's what I'm going to do. But I'm not going to draw. I'm going to draw parts. Okay. So I drew a gigantic circle. Then the arc length of this circle, that's my arc length. It's pretty much the diameter, right? Because it's such a flat spot in a gigantic circle. So the diameter of Mars is pretty much the same as the arc length of the gigantic circle, right? So then the problem becomes pretty easy. Because we're going to just use the S equals R theta because it's in radians, right? So I'm just going to use S equals R theta. So the arc length is the diameter. So that's what I want to find. So S equals my 5 times 10 to the 7th times my degree, or my
5.8.
5.8, yes. Thanks, Carly. What is, yes, 5.8. Thanks, Carly, times 10 to the 7th times my angle, which is 0.00014. Okay, and I'm just going to use my calculator. Clear. 5.8, thanks, Carly, times 10 to the 7th times my 0.00014 radians. Oh my goodness, I hate when it does that. Delete, 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 delete. Thank you, Career. I heard that. You're like, Mr. Davies. 1.4. And so it's about 8,120 kilometers for the diameter. 8,120 kilometers, the diameter of Mars. If I use the correct numbers. I probably made these numbers up, so we could probably look it up and see how far off I am. But anyway, that's the basic gist of it, okay? All right, I'm going to stop there. I have a little bit of assignment.